Hello students, this is Saxon Algebra 2, Lesson 22A, which is entitled Uniform Motion, Equal Distances. We covered uniform motion problems in Algebra 1, so this will be a short summary video. To start, terminology and formula review. Uniform motion means that the speed doesn't change in the problem. And the formula, distance equals rate times time. And remember that rate and speed are the same in algebra. They'll be different in physics, but we're not in physics, we're doing algebra. So they use the terms rate and speed interchangeably. Suggestion: practice drawing a diagram for each problem. This will help you later when the uniform motion situations get a little more complicated. Now we will simply go over the examples. I find a little chart to be very helpful in setting up uniform motion problems. I set it up like this. There are usually two situations that you're comparing, and I have rate times time on one side and then a thick line, and that equals distance. I will fill in this chart as we read the problem. I suggest that you do too. You make your own little chart and fill it in as we read the problem. Oh dear. Example 1. Example 1. Roger made the trip on Sunday and Judy made the same trip on Monday. This is when you should be filling in Roger and Judy. Those are the two different examples, the two different situations. The same trip means the distances were equal. Roger traveled at 12 miles per hour. Judy traveled at 20 miles per hour. So her time was 2 hours less than Roger's. This is where you want to choose your variable carefully. If you make Roger's time t, then Judy's time can be t minus 2, 2 hours less than Roger's. And the question in the problem is, how far did they travel? Well, we can now fill in the distances. So Roger traveled 12t miles, and Judy traveled 20 times t minus 2 in parentheses miles, and the distances are equal. So 12t equals 20 times t minus 2. And the rest is algebra. You know how to do it. Let's do example 2. There's the chart ready to go. Example 2. Brer Rabbit hopped off toward the briar patch at 10 kilometers per hour at 10 a.m. So we've got a rabbit and we have a rate, 10 kph. But there's no place in the chart for starting times, so we're going to need a diagram for that. At noon, Brer Wolf began the chase from the same starting point. That will become important. So we've got a wolf. If he caught Brer Rabbit at 2 p.m., how fast did he run? So the problem is asking us for the wolf's rate. So we'll set that equal to x. And since he caught Brer Rabbit at 2 p.m., the problem ends at 2 p.m. And you can see they both traveled the same distance. They started from the same starting point, and when it was over, Brer Wolf had Brer Rabbit in his mouth. So here's a diagram to include the times. So the rabbit ran from 10 a.m. to 2 p.m. for a total of 4 hours, and the wolf ran from 12 p.m. to 2 p.m., which was only 2 hours. Now that we have the times, we can find the expressions for distance. The rabbit ran 10 kph times 4 hours, so the hours cancel out, and the rabbit ran for 40 kilometers, and the wolf ran for 2x kilometers. The distances are equal, so 2x equals 40 kilometers. And the rest is algebra, almost. I wrote the equation as 2x equals 40 kilometers. But let's think about the units. Remember that we are looking for the wolf's rate. That means that the units on x are kph, kilometers per hour. The 2 represents 2 hours. So when you set up the math, you have 2 hours times x equals 40 kilometers. And when you do the math, you have x equals 40 kilometers divided by 2 hours, and you get x equals 20 kilometers divided by hours. And of course, kilometers divided by hours is kph. Units are important. The wolf's rate is 20 kph. I hope this video helped you to master this part of the lesson. See you next time.